Good morning to one and all gathered here. So we are having a PhD Viva in quick succession. 2 days ago we had one. Today we have the 24th candidate defending her thesis. And she's the 13th student of Dr. Usha. So this is another Viva on X-ray crystallography. So we have the best person in this field to witness the defending of the thesis. So Brahma Shivaya, she's going to get appreciation, I guess. So my hearty welcome to the ever, what shall I say, enthusiastic researcher, Dr. Vel Murugan. We are all just ants in front of them. So the impetus that we gain is when our research guide comes to witness our students' Viva. So it's not easy, for Usha to get her guide's presence over here is possible only if she has been very sincere, meticulous, and truthfully a obedient student. Neither aspect is missing. Why I am saying this specifically is this aspect of genuine sincerity and obedience to the Guru is missing in this generation today. So I want her students to imbibe this very important quality. When you want to go up the ladder, the Guru Bhakti is very, very important. See, but for it, definitely a man who is an octogenarian coming here to bless her student is something impossible. So please, your education is meaningless if you don't have any values and ethics. Your PhD has no value, please take it from me, if you don't have all these traits. Submitting a thesis, getting a report, all that is guide's duty. And you are nothing just after completion of PhD. That's the first step. To go further, you really need the blessings and the support of your guide. So I request you people to develop that quality, especially that from Dr. Usha. Then we have a very nice examiner, my good friend next door, Dr. Mohan Kumar. I admire him for his simplicity and what shall I say, really friendly or respectful person. I always keep him. No airs. You can call him as for a UG examination as an examiner. You can call him for a PhD as an examiner. He never says senior, junior. Excellent person, I must tell you. We are actually batchmates, though not classmates. When I was doing MPhil in Anna University, he was doing his MPhil in nuclear physics department. So 35, 38-year-old friend. Very nice to have you here as a PhD examiner today, sir. He is an excellent researcher in the field of crystal growth, and he is also doing a little bit of nano. He has guided over 16. Double digit now. I am nowhere near them. So he has guided over 16 students, and about 4 or 5 are still doing research under him. 200 plus. 40 papers reach casually he's telling 200 plus. So I'm not at all the right person to talk about them. I'm standing here just because of my position. Really inspirational people are here, and I'm sure he will deliberate with good questions and give you suggestions for further research. And we have the best people here. I heartily welcome all my department colleagues, all the students of the department, and people from other departments who have come. Actually, we expect a big gathering usually. Today there is a union valedictory function going on, so the entire crowd is in DJ hall. The one who are purely connected in physics are the ones who are here. So without taking much time, I request Usha to take over and then hand over the session to the external examiner. Once again, a warm welcome to all of you.
Very good morning and warm welcome to each and every one of you present here. I feel very happy and privileged to extend my hearty welcome to my Guru, director, Dr. Professor D. Velmurugan, former head of the Department of Crystallography and Biophysics, University of Madras, Gindi campus. Right now he is the Dean Research, placed in SRM University, Katangrapur. But for him, I am standing now in front of you to conduct the Viva examination of my 13th student, Mrs. Angeline. I feel very happy and I feel pride to introduce Mrs. Angeline Shirmila, the candidate for today's Viva examination. Angeline, she is filled with values and ethics. She is sincere, knowledgeable, excellent worker, highly organized person, and above all, she is humble and polite. So now, I'd like to place some credentials of her achievements as a research scholar. She has won the Best Oral Presentation Award during the Conference on Advances in Material Science conducted by Manonmaniam Sundaranar University, Tirunelveli, and Best Flash Presentation during the Conference on Trends in Small Molecule Crystallography conducted by Indian Crystallographic Association. And she also won the Young Researchers Award during the Conference of Physics Academy of Northeast conducted by Tripura University. So she is very talented, and during her research period, she has done some good quantum of work on the topic synthesis and characterization of 5 newly synthesized compounds for their biological and industrial applications. And out of her research findings, she has published 4 papers in the internationally reputed journals. I believe and I hope that she will defend her thesis for the next 30 to 40 minutes effectively. On behalf of you and my own behalf, I wish her all success in her endeavor.
A very good morning to one and all present here. I am the Angeline Shirmila, a research scholar, going to defend my thesis on the topic synthesis and characterization, 3D crystal structure determination, Herschel surfaces analysis, biological activity studies, and molecular docking studies of tetralon-based chalcone derivatives. I have done this research work under the guidance of Dr. G. Usha, Associate Professor, PG and Research Department of Physics, Queen's College, Chennai. The objectives of my research work was to synthesize a series of tetralon-based chalcone derivatives which are biologically active as well as serve as a functional material for industrial application, to determine the crystal structure by single crystal X-ray diffraction, to estimate the geometrical parameters such as bond length, bond angles, torsion angles, dihedral angles, conformation of ring systems, and molecular packing in the unit cell, to study the molecular interactions, short contacts, and energy framework using Herschel surface analysis, to screen the synthesized compounds for their toxicity, anti-cancer, antifungal, antibacterial, antioxidant activities, to study the active site interactions between the ligands, that is the synthesized small molecules, and protein by docking studies, to characterize the synthesized compounds using HNMR, CNMR, FTIR, UV, PL, and lifetime analysis, and to study the thermal properties by TGDTA. Contents of my research work are as follows. Chapter 1 gives the detailed introduction about Medicinal and industrial importance of the dipole synthesis, 3D crystal structure determination, Herschel surfaces and energy framework analysis, biological activity studies, molecular docking studies, and optical and thermal characterization techniques. Chapter 2 explains about the synthesis procedure, X-ray crystallography, and procedures followed for crystal structure determination and various crystallographic parameters. This chapter also deals with Herschel surfaces analysis of a molecule in a crystal structure, 2D fingerprint plot, and energy framework studies to visualize the intermolecular interactions in the Chapter 3 deals with biological activity studies and molecular analysis of the as-synthesized chalcone derivatives. Chapter 4 enumerates the results and discussion of various characterization studies such as NMR, FTIR, UV, PL, lifetime analysis, and TGDTA. These studies were carried out to understand the physical, chemical, optical, and thermal behavior of as-synthesized chalcone derivatives. Chapter 5 catalogues the comparative analysis of various studies which are conducted on the synthesis compounds, and the conclusion is also listed here. And an introduction to chalcone. Chalcones are natural compounds belonging to flavonoid family and are widely distributed in plants, fruits, vegetables, grains, bugs, etc. Chalcones are a class of natural open-chain flavonoids that are linked by a 3-carbon spacer between 2 aromatic rings. Chalcones possess a broad spectrum of biological activities, including antibacterial, antifungal, antiviral, insecticidal, antioxidant, etc. Changes in the structure have offered a high degree of diversity that has proven useful for the development of new biological products having improved potency, lesser toxicity, and good pharmacological action. Glacial skin condensation technique is the general synthesis method of chalcone, which is the condensation of equimolar ratio of an aromatic aldehyde with ketone in the presence of a liquid alcoholic alkali, results in the formation of an alpha-beta unsaturated carbonyl group. Synthesis procedure. The A compound that I chosen is 3,4 dihydro 2H naphthalenone. The common name of this is alpha-tritolone. The B compounds that I have chosen for synthesis is 2,4 dimethoxybenzaldehyde, 4-benzyloxybenzaldehyde, 3,4 dimethoxybenzaldehyde, 3,4,5 trimethoxybenzaldehyde, 3-hydroxy-4-methoxybenzaldehyde. Using glacial skin condensation technique, that is the most common, effective, and convenient method used for synthesizing chalcone derivatives in the laboratory. I have synthesized all the 5 compounds. In the current research work, all the 5 compounds were synthesized by adopting this technique and crystallized by slow evaporation method. An equimolar ratio of A and B was dissolved in absolute alcohol in a 250 ml conical flask and was stirred for about half an hour. Freshly prepared 10% MU2 solution was added to it, the mixture, and stirred again for 1 hour. This mixture was kept aside for ambient temperature, that is 24 hours, and then poured into ice cold water. And yellow precipitate was formed, which was washed with distilled water to remove any traces of any hoosh. The filtered, dried product was recrystallized thrice in acetone, and after 2 to 7 days, good quality yellow block crystals were harvested. These are the images of the crystal that I have obtained. Reactors used in the chemical reaction, product, IUPAC name, solvents used in the procedure, color and nature of the crystals formed are enlisted in this table. Acetone was found as the suitable solvent for all of my compounds except TMMD, where 1:1 ratio of acetone plus ethyl methyl ketone is mixed and used as the solvent. Reaction scheme of all of my 5 compounds are enlisted here, where A and B are combined to get the final product. 3D crystal structure determination, Herschel surfaces analysis, and energy framework analysis. Diffraction quality good block crystals were grown and were given for single crystal XRD for data collection. 3D structure of the crystals were solved using Shell XS97 and Shell XT 2014 bar 4, 2014 bar 5, and refined with Shell XL 2018 bar 3. The molecular graphic plots were drawn using Platon. Herschel surfaces analysis is a valuable tool in crystallography that helps us in studying different types of non-covalent interactions present within a crystal structure and the topology of the intermolecular interactions representing the network of nearest neighbor energy. The Herschel surfaces of the compounds and the 2D fingerprint plot were developed using Crystal Explorer 17.5 using ZIP file as the input. The software used in the research work are enlisted here in this slide. Crystallographic data of all the 5 compounds are enlisted here. The compounds DMMD, BMMD, and HMMD crystallized in a monoclinic crystal system with the compounds PMMD and TMMD crystallized in orthorhombic crystal system with space group as follows. It is P21 bar N, P21 bar C, P21 PBCN, P21 bar C. After refinement, the R factor was found to be for DMMD, BMMD, PMMD, TMMD, HMMD, that is 0.04, 0.57, 0.057, 0.073, 0.039 respectively. Crystallographic parameters analysis of the compound DMMD. The non-coordinate interactions of the compound DMMD are enlisted in this table. 30% probability level autograph diagram of the compound is shown here. The CC bond distance in the cyclohexanone is in the range 1.483 to 1.517, and of the aromatic ring is 1.376 to 1.413 angstrom. C double bond C distance is 1.341, and C single bond distance is 1.364 to 1.423 angstrom, and C double bond O distance is 1.228 angstrom. And all these values are in the normal range and are comparable with the reported values. The torsion angle C9, C18, C9, C8, C11, C12 has a 4.9 degree, which indicates that the phenyl ring C12 to C17 has a plus syn periplanar orientation with the tetragon moiety C5 to C10. The equatorial arrangement of the atoms between the phenyl rings is revealed by the dihedral angle of 65.14 degree. The packing diagram is viewed along A axis and it shows that there is no specific interaction between the molecules. The crystal packing is stabilized only by van der Waals forces. The cyclohexanone ring of the tetragon moiety exhibits a distorted half-shell conformation. Here, in the crystallographic details of the compound BMMD, the bond distances are in the normal range and are comparable with the reported values. The torsion angle with minus 5.6 indicates that the phenyl ring C12 to C17 has a minus syn periplanar orientation with the tetragon moiety. The bisectional arrangement between the phenyl ring is revealed by the dihedral angle of 51.32 degrees. The molecules are alternately stacked by 2 or 3 molecules forming clusters viewed along C-axis. The crystal packing is stabilized only by van der Waals forces. Here the OTEP diagram of the compound with 30% probability level is shown here. The cyclohexanone ring obtains the distorted half-shell ring conformation. Crystallographic parameter analysis of the compound PMMD. The hydrogen bonds of PMMD are shown here. The OTEP diagram of the compound with 30% probability level is shown here. The CC bond distance, C double bond C distance, CO bond distance and C double bond O distance are all in the normal range and are comparable with the reported values. The torsion angle minus 2.81 indicates that the phenyl ring C12 to C17 has a minus syn periplanar orientation with the tetragon moiety. The bisectional arrangement between the phenyl rings is revealed by the dihedral angle of 51.993 degrees. The packing diagram shows that the molecules are packed in a zigzag orient head-to-tail parallel fashion along the C-axis. The cyclohexanone ring adopts a distorted half-shell ring conformation. The crystallographic parameters of the compounds TMMD, the hydrogen bond table is listed here. The OTEP diagram with 30% probability is shown here, and the bond distances are in the normal range and are comparable with the reported values. The torsion angle minus 5.6 degrees indicates that the phenyl ring C12 to C17 has a minus syn periplanar orientation with the tetragon moiety C5 to C10. The bisectional arrangement between the phenyl ring is revealed by the dihedral angle of 51.86 degrees. Packing diagram shows that the molecules are packed in a sheet running along A-axis. That cyclohexanone rings adopt a distorted half-shell conformation. Finally, the parameters of HMMD, non-coordinate interaction of HMMD is shown in this table. The OTEP diagram with 30% probability level is shown here. The bond distances are in the normal range and are comparable with the reported values. The torsion angle 10.23 indicates that the phenyl ring has a plus syn periplanar orientation with the tetragon moiety. The bisectional arrangement between the phenyl ring is revealed by the dihedral angle of 41.1 degrees. The crystal packing is viewed along B-axis and is stabilized only by van der Waals forces. The cyclohexanone ring of the tetragon moiety exhibits a distorted half-shell conformation. Hirschfield surfaces analysis. Using zip file as the input to the Crystal Explorer Sample 2.5, Hirschfield surfaces were mapped over denorm electrostatic potential, shape index, curveness, fragment patches to represent the molecular interactions visually. Hirschfield surfaces smoothly encloses all of the available space around the molecule. D norm is the normalized contact distance. DE and DA are the distance between the Herschel surface and the closest external and internal nuclei respectively, and are normalized by the van der Waals radius of the atom involved. The sum of these two quantities is the D norm property. Herschel surface is mapped with D norm uses red, white, blue color scheme, where the red color indicates shorter intermolecular contact that are less than van der Waals radii, white color indicates contacts around the van der Waals radii, and blue color used to indicate the longer contact distance that is greater than van der Waals radii. In shape index, the appearance of red and blue triangles indicates the presence of CH5 pi stacking interactions, which are also confirmed by the curveness by flat areas on the mapped surface. Curveness is a function of root mean square curvature of the surface, with flat areas of the surface having a low curveness and areas of short curvature having a high curveness. The color patches on the Herschel surface depends on the closeness to the adjacent molecule. It provides a convenient way to identify the nearest neighbor coordination environment, thereby the coordination number. In electrostatic condition of the Herschel surface, the donors and acceptor are shown as blue and red regions around the atom. From D norm map, the strong CHO interactions are visualized as bold red spots between the respective donor and acceptor atoms. Herschel surfaces mapped over the electrostatic potential shows the negative potential around the acceptor, red color clouds, and positive potential around the donors, those are the blue color clouds. The presence of adjacent red and blue triangles in the shape index shows the presence of CH5 pi interaction with the phase compounds, and which is confirmed by the flat regions in the curveness. The coordination number of DMMD, BMMD, HMMD were found to be 16, whereas the coordination number of PMMD was 14 and PMMD was found to be 17 using the fragment patches. 2D fingerprint plots. Two-dimensional fingerprint plots provides the fingerprint of intermolecular interaction with the crystal. It indicates the type and also the relative area of the surface corresponding to each kind of interactions. Figure showing 2D fingerprint plot of interactions present along with relevant Herschel surface are mapped with D norm. For all the 5 compounds, HH contact contributes the highest to the total Herschel surface. CH contacts contributes the next highest. HO contacts also contribute significantly, but the contributions due to CC, CO, and OO are very less. The fingerprint plots of 2D fingerprint plots of DMMD shows the HH contact contributes the highest of 54.1% to the total Herschel surface. CH contact contributes 23.8%. HO contact contributes 17.4% contribution, and the contribution by other contacts are very less. Similarly, in DMMD also, the HH contributes about 51.7% to the whole Herschel surface. CH contact contributes the next highest of 33.9%. HO contact contributes significantly of about 12.2%, and contributions by other contacts like CC, CO, and OO are very less. The 2D fingerprint plot of PMMD reveals that the HH contact contributes the highest, CH contacts contribute the next highest, HO then comes the next, and the contacts due to CC, CO, and OO are very less here also. The in PMMD compound, the HH contacts contributes the highest with 52.7 degrees, CH contacts contributes the next highest 26%, HO contacts contributes 20.6% to the total Herschel surface. Contribution by other contacts are very less. Finally, the HH contacts due to the compound in the compound HMMD is 47.8%, CH contributes 26.4%, HO contacts contributes 19.1%, CC contact contributes 4.3%, CO contributes 2.1%, and OO contributes 0.3%. Energy framework analysis. Intermolecular interaction energies can be calculated and represented with their magnitude using energy framework. The component of energies are electrostatic, polarization, dispersion, and exchange repulsion. The total interaction energy, which is the sum of the scale component, was calculated for a 3.8 angstrom radius cluster of the molecules around the selected molecule of the title compound using the energy model CeB3LYP. The total energy is the sum of the scale components. The scale factors for the benchmark energy models are given in this table. Energy between adjacent molecules are represented by cylinders joining the centroids. Cylinder's radius is proportional to the magnitude of the interaction energy. Energy frameworks were constructed for electrostatic energy by red cylinders, dispersion energy by green cylinders, and total energy by blue cylinders. Energy framework of DMMT. The energy calculation was done for 2 cross 1 cross 2 unit cell for the tidal compound. The table shows the results of the interaction energy, which reveals that the dispersion component is significant. The total energies were found and enlisted here. And the dispersion energy was found to be minus 2.38 kilojoules per mole. Energy framework of DMMT. Here also the unit cell has the dimension 2 cross 1 cross 2. The table shows the results of the interaction energy, which reveals the dispersion component is maximum to the total Herschel energy. In PMMT also, the dispersion energy contribution is most significant to the total Herschel energy. In the compound TMMT, the dispersion energy contribution is most significant with minus 234.3 kilojoules per mole. Finally, in the compound HMMT also, the dispersion energy contribution is most significant to the total energy with dispersion energy value minus 264.7 kilojoules per mole. Biological activity studies. The cytotoxic effect of the as-synthesized tetragon-based chalcone derivatives on normal cell lines were screened for the various sample concentration. In vitro antibacterial, antifungal, antioxidant, anti-cancer activity of the compounds have been studied. Antibacterial activity of the compounds were determined by disk diffusion method on Muller-Helmholtz agar medium against 2 gram-negative bacteria, namely Salmonella typhi coli, and 2 gram-positive bacteria, namely Staphylococcus aureus and Streptococcus sp. Disk diffusion method was employed to study the antifungal activity of the synthesis compounds against Candida albicans, Aspergillus niger, and Trichoderma viridae. The MTT assay was performed to assess the cell viability. It is observed from the IC50 values that all the title compounds were non-toxic on normal Viva cell lines. MTT assay also has been performed to comprehend the efficacy of the compounds against the procreation of cancer cells and found to exhibit excellent anti-cancer activity even at low concentration of the title compounds. The zone of inhibition of on the bacterial strains are enlisted in the, for all the 5 compounds are enlisted in this table. Ampicillin was used as the reference drug, and the compared results shows that the antibacterial activity was intermediate, and the antibacterial activity was determined by measuring the diameter of the zone of inhibition in millimeter. These are images showing the zone of inhibition of the antibacterial activity of my compounds on the list. Compounds BMMT and PMMT shows intermediate resistivity against the strains, while DMMT shows a moderate resistivity. Antifungal activity. Zone of inhibition on the fungal strains are enlisted for all of my compounds. Standard drug amphotericin was used to compare the results. Antifungal activity was determined by measuring the diameter of zone of inhibition. All the compounds exhibited better activity on fungus Aspergillus niger than the standard reference and can be considered as potential candidate for drug design after preclinical testing. These are the zone of inhibition of my compounds on the various fungal strains. Compounds are observed to exhibit intermediate antifungal activity against the testis microorganism. Among the 5 compounds, BMMT shows a better activity against the fungal strain Aspergillus niger. Antioxidant activity. Antioxidant activity is the scavenging of free radicals from body cells and prevention or reduction of damage caused by the oxidation. All the synthesized compounds were screened for antioxidant activity by using the standard free radical scavenging DPPH method. The percentage of DPPH inhibition is calculated and is the measure of percentage of antioxidant activity. All the 5 compounds are found to have significant antioxidant activity. Cytotoxicity activity. All the synthesized 5 compounds were screened for the cytotoxicity on normal Viva cell lines using MTT assay. Measurements were performed and the concentration required for a 50% inhibition was found out. The non-toxic effect of the compounds was tested for concentration ranging from 1000 to 7.8 mg per ml. It is noticed that the cell viability decreases with increase in sample concentration, which indicates that all the title compounds are non-toxic even above 1000 μg per ml. Image showing cytotoxic effect of the title compound. The morphology on Viva cell line shows that all the synthetic compounds are non-toxic to normal cell lines. Anti-cancer activity. MTT assay method was used to study the anti-cancer activity of the synthesized compounds against MCF7 breast cancer cells. It is observed from the activity studies on the MCF cells, that is the mystical foundation 7 cells, that cell lines, that the cell viability decreases as the sample concentration increases. The viability of the compound is recorded for varied concentration, and the compounds showed very good inhibitory activity against MCF7 cell lines. The morphology changes on MCF cell lines of all the title compounds are shown here. The title compounds DMMD, BMMD and TMMD shows excellent anti-cancer at a very low concentration of 7.8 mg per ml, 15.6 mg per ml respectively. This indicates that the capacity of these title compounds to inhibit the proliferation of breast cancer cells. Docking analysis. Molecular docking was performed to decrypt the chemical interaction and binding conformation of the compounds in the binding sites of target protein against breast cancer. The ligand-target interactions are studied using Autodoc 4.2.6 software package, and 5-on graphics software was used for the preparation of protein target and also to view the interaction between the ligand and target. In this work, the ligand interaction with protein 1M17 corresponding to the appropriate run exhibits the lowest binding energy values were tabulated. The image showing the interaction of the available drug erlotinib with the protein target is shown in image A. The ligands DMMD interacts with protein 1M17 is shown here in the image B. The interaction of BMMD with the protein 1M17 is shown in C. The images D, E and F shows the interaction of PMMD, DMMD and HMMD with protein 1M17. Binding energy obtained by molecular docking simulation of the ligands with the target protein is enlisted here. The title compound DMMD, BMMD and TMMD exhibits lower binding energy value of minus 10.27, minus 9 and minus 10.96 kilocalorie per mole respectively, corresponding to RAD4. The compounds PMMD and HMMD exhibits lowest binding energy of minus 10.57 and minus 10.11 kilocalorie per mole, corresponding to RAD 7 and 3 respectively. The amino acid residues present in the active site of the available drug erlotinib is listed here. The molecules of all the 5 compounds fits well into the inhibition site of 1M17 protein and have interaction bonds with the amino acid residues MET769. The same interaction can be visualized in the available drug molecule erlotinib also. In addition to this, all the molecules interact with lysine 721, which is present in the active site of the reference drug molecule. Out of the 5 compounds, TMMD showed a better docking results with the lowest binding energy of minus 10.96 kilocalorie per mole. In silico molecular properties. In silico computational studies were performed using Mold Inspiration Online Property Calculation Toolkit to determine Lipinski's parameter. Lipinski's rule of 5 is a rule of thumb to evaluate drug likeness and to determine if a chemical compound with certain pharmacological or biological activity has chemical and physical properties that would make it a likely orally active drug in humans. Properties such as molecular weight, hydrogen bond donors, hydrogen bond acceptors, number of rotatable bonds, log P value, molecular refractivity and the total polar surface area was estimated for the title compound based on Lipinski's rule of 5. Compounds violating more than one of these rules will have bioavailability problems. The pharmacokinetics of the orally active title compounds were predicted using Swiss Army web server. The drug likeness score for all the compounds are listed here. All the compounds obeyed Lipinski's rule of 5 except for BMMD with one violation. The pharmacochemical properties of the compounds are listed here in this table. All the compounds exhibited good pharmacological profile with high gastrointestinal absorption, good synthetic accessibility score, and molar affinity in the range 80 to 100. Spectral characterization. The physical and chemical property of the synthesized chalcone derivatives were investigated for various spectral and thermal studies. Proton and carbon NMR analysis was carried out to estimate different types of protons and carbon atoms in the molecular structure of the compound. FTR spectral studies were performed to examine the stretching, bending vibrations present in the compound. UV visible spectral analysis was performed to analyze the optoelectronic behavior of the compounds. The emission features of the compounds were investigated using PL analysis. Lifetime analysis was used to find the mean lifetime of the compounds. Thermal stability of the compounds is estimated by using TGDTA thermograms. The HNOR spectrograms of all the synthesized compounds are shown in this slide. The chemical shift values of different types of proton present in the molecule are in good agreement with the range of the literature values. The CNMR spectrograms of all the 5 compounds are displayed here. The chemical shift values for different types of carbon atoms present in the molecules are in good agreement with the range of the literature values. The FTIR spectrum of all the 5 compounds are displayed here. All the values are in good agreement with the range of the literature. One such characteristic peak is C double bond O stretching, which confirms that the chalcone derivative. The characteristic C double bond O stretching peak of chalcone's derivatives are present for all the 5 compounds and are comparable in the range with literature values. The UMS analysis identifies the preferential absorption by the compound, transparent region, and cutoff wavelength. The band gap energy of all the 5 compounds were calculated using this formula and listed here in the table. The absorption peak and cutoff wavelength are also found on the graph and listed here. The PL study analyzes the emission spectra of the compounds. In the PL spectra of the compounds, the peaks were found to be present around 350 nanometer. Corresponding to the fluorescence peak, the peak values around 470 in the spectra correspond to the fluorescent peaks. These phosphorescent peaks values are falling in the blue light emission range, that is 400 to 525 nanometer of the visible spectrum. Thus, all the 5 compounds can be used as blue light emitters in the optoelectronic engineering. Emission peak are listed here. Lifetime analysis. The exponential decay data tau 1, tau 2, tau 3 was fitted the 3 exponential model and the corresponding emission decay components B1, B2, B3 were used to calculate the average lifetime tau average here, and it is shown in the table here. TGDTA thermal studies of the compound. TGDTA thermal analyzes the physical and chemical changes due to increase in temperature and hence the thermal stability. Simultaneous TGDTA was done to obtain the thermogram of the synthesized compounds in nitrogen atmosphere at a rate of 10 degrees C per minute from room temperature to 1000 degrees C. The initial weight, melting point, and residual weight are listed in this table. The grown crystals exhibited moderate thermal stability from 167 to 286 degrees C. Kinetic and thermal parameters of the compound. The shape of the TG curve depends on the kinetic parameters such as rate of reaction, frequency factor, and activation energy. A plot of Coates-Richmond was drawn for all the synthesized compounds for various values of n. The correct value of n was found from the best fit linear plot. The best fit was obtained for n is equals to 0.1 for the compounds DNMD, TNMD, and HMMD, and n is equals to 0.5 and 0.7 for the compounds VMMD and PMMD. The kinetic and thermal parameters were calculated, that is the activation energy, frequency factor, enthalpy, entropy gives free energy. The negative values of the enthalpy and entropy specifies the exothermic nature of the reaction, needs an external agent to reduce the reaction process. The reaction was considered to be thermally unstable because of the resulting positive values of its free energy. Conclusion. A series of 5 tritone-based chalcone derivatives were synthesized using Claisen-Schmidt condensation reaction with slow evaporation method. The grown crystals were studied for their 3D structure and crystal parameters. Single crystal XRD was used to determine the molecular structure, chemical bonds, and intermolecular interactions. Herschel surfaces were mapped over genome, electrostatic potential, shape index, curveness, fragment patches to visualize the intermolecular interactions and also to identify the CH pi interaction and pi stacking using Crystal Explorer 17.5. 2D fingerprint plot was analyzed for the corresponding Herschel surface to understand the percentage of various contacts that has contributed for crystal packing of the compound. Intermolecular interaction energies were calculated and represented diagrammatically using energy framework analysis. From the results obtained, it is evident that the contribution of dispersion energy is most significant to the total Herschel surface. The compounds were screened for their biological activities such as antibacterial, antifungal, antioxidant, cytotoxicity, and anti-cancer activity. All the compounds are moderately active against bacteria and fungi but exhibits good antioxidant activity. The cytotoxicity study shows that IC50 values of all the 5 Title compounds are greater than 1000 mg per ml, which indicates that the compounds are almost non-toxic to non-viral cell lines. Anti-cancer activity on breast cancer MCF7 cell lines suggests that the compounds have significant anti-cancer activity. Docking studies revealed that the compounds can be considered as the lead material in designing new drug against breast cancer after preclinical testing. Molecular docking was performed to find the best fit of the small molecules at the active site of the protein target 1M17. All molecules bound well at the active site and also had interactions with amino acid residues MET769 and lysine 721. The pharmacokinetic profile of the compounds showed no violation against Lipinski's rule of 5 except BMMD, which shows one violation. Thus, the synthesized compounds were found to be eligible candidates to be nominated for drug designing to fight against breast cancer after authentic preclinical testing. The physical and chemical behavior of the synthesized compounds were studied with the help of UV, NMR, FTIR, PL, lifetime analysis, and EGDT thermographs. The stretching, bending, vibrations of the compounds have been assigned with the frequency range in the comparison with the literature. Identification of different types of carbon and proton was done with NMR analysis. Lifetime analysis was performed to estimate the fluorescence property of the materials, and their average lifetime was calculated. Thermal studies helped in determining the melting point, purity of the sample, and the decomposition process. Future scope of my research work: the synthesis compounds exhibited good biological activity, especially very good anti-cancer activity against breast cancer cell lines. In future, in vivo analysis along with authentic preclinical testing can be performed to upgrade the compounds to become a suitable drug to inhibit the proliferation of breast cancer cells. As the compounds display characteristic peaks in the blue light emission region, they can be manipulated and modified to serve as blue light emitters in optical devices. In nonlinear optical activity can be done to find the efficacy of the compounds in the optoelectronic device manufacturing field. List of publications: I have published 4 papers in international journals. List of papers presented at conference: I have attended and presented 6 national conferences, and out of that I have received the best oral presentation, best flash presentation, and young research award in 3 of the papers.
Good morning, everyone. First of all, I want to thank Supervisor and also I thank Professor Angeline for coming over here for to attend this examination. It is easy for me. The professor is here. So it's a best endorsement of this Viva because of process synthesis. So it is a good interaction. So very nicely presented the results here. And as a part of the examination, so the exam about the Indian exam, the coordinating work to given the comments. Before going further to examination, conduct the reports. So we should ask participants or scholars to have any question or clarification or questions. Because examiners, they ask only a few questions.
I have a question on Hirschfield analysis. Do you have any explanation as to why HH contacts contribute maximum to Hirschfield surface in all your compounds, whereas CC and CO contributions is the minimum? Do you have any explanation for it?
The electron density around the edge, that is yes, ma'am. My compound is stabilized only by van der Waals force and it is conformed by the HH contacts that are present in the
tertiary results.
Admin properties, I can understand the role of BBB and intestinal absorption and all.
Okay.
What role does molar refractivity play?
Molar
What do you mean by molar
It is a
refractivity?
criteria that is present in the Lipinski's
So
law.
what is molar refractivity?
Molar refractivity, it is the ratio of
Water soluble should be then affecting the.
that is, it should be between the molar refractivity values should be between 80 to 100.
Yeah, I understand, but what role does it play for a pharmaceutical compound? Because as far as I know, refractivity is something to do with light. And what is this? I don't know. I want you to tell me. What do you mean by molar refractivity? How does it play a role in deciding that the compound can be a drug? Or has it been taken just because the software gives this output?
No, actually the Lipinski formula 5 also in this year, and it has been verified by the software.
Now, what is molar refractivity? I want to learn from you.
Anything else? Professor Muralidharan is a dean in which campus. He assessed his thesis and gave a book on merit of the thesis. It's run over 4 pages, merits and so that's a point in, as he said, there is no specific B merits of the thesis are found out. And, so is there is any reason? Why do you choose these 4 compounds, which is used in the chemistry?
So before starting the research, I have focused my concentration on biologically active compounds. So after careful literature survey, I found that tetralone-based carbon derivatives had high biological activity. So I just substituted the functional groups, that is the methoxy position at methoxy groups at para position were found to be more effective and biologically active. So I chose the compounds on that basis and synthesized them.
And any steps it is involved in drug discovery?
Drug discovery is the basic thing before drug development. The compounds has to be synthesized
It
first.
is a general question he asked regarding your
Yes, the first.
compound. See, this tested with the tested.
Yes.
So that's why he asked you
Yes.
the steps that is involved in the
Drug discovery involves the synthesis of the compounds.
based on your compound.
Yes, there are synthesized 5 compounds, which then I determine the structure of the compounds. After determining the structure, I went for the characterization. Next, the biological screening was done for various antifungal, antibacterial, anti-cancer, etc. Then I found that antibacterial, anti-cancer activity was there. Then the molecular docking was performed based on the breast cancer cell line. Because of the anti-cancer activity, I took the 1M17 protein for docking analysis. After docking only, I said that after preclinical testing that bioavailability score were also very good for my compounds. So I decided that it can be considered as a drug material. This is the process steps involved in drug development.
Almost you have done all the
Yes.
all the
Discovery stage. The next is drug development, preclinical testing, clinical testing. Then it has to be approved by the TDSCO. Then only the drug can come to the market. If it it is
So that's why he asked for the final stage.
After this, you have to induce the diseases in animals.
Animals, that is the preclinical testing. First stage is preclinical, that is the inducing on animals. Then if it is working out correctly, then the human beings will be given the dosage according to their body capacity, that is the clinical testing.
How will try the
Clinical trial,
how many phases? How many phases?
clinical trials. That is development stage.
Standard. 3 phases, generally. 3 phases.
3 phases.
100, 200, 500. So after that also, after giving the drug, they have to wait for the response to the patient. Generally, 4.
There is any idea rule of
Yes, Lipinski's rule of 5. Hydrogen bond donors should be less than 5. Hydrogen bond acceptor should be less than 10. Log P value should be less than 5. What? Log P values like less than 5 pound mix. Then molar refractivity value should be
Important point on missing. First rule. Molecular weight.
molecular weight should be between it should be less than 500 daltons.
Why is that? Why is this not 5?
It,
5 units are.
sir, it should be a small molecule for
5 is agreement.
5
Not 5 units.
5 should be in agreement.
No, no. Is agreement, no.
Okay.
5 is agreement. You don't have 5.
Okay, that is called as noted.
that is related with the ask any questions because satisfied with your results and the appreciated words in his comment. So it's an original document reporting the novel scientific information, and it is effectively presented all her findings, and throughout the thesis, the tables and tables are excellent quality, and all references it is cited to the running test, like that appreciated words. Finally, the crystallography questions like the basic crystallography fundamentals and methodology that is involved in this direct motor and the molecular modeling, the stereochemical properties of small biologically active, and also the tracking of the small molecules in the active site of the molecules. That related with the questions, so maybe asked during the asked. And based on that, I have some questions. So that is Professor Sagas. In some places you put absolute value. So only the table you put acetone or the other solvent. So only put
Absolute alcohol is nothing but ethanol.
What do you want? We are saying the name, absolute.
It is a synonym. Absolute alcohol is maybe the percentage of unique.
Also in the synthesis part, they put sodium hydroxide.
Yes. It is a base catalyst that is present below. So it uses the water molecule to activate them, and it helps in precipitation. It's yellow color something only after adding the 10% of ammonia solution to the mixture of A and B.
It seems that it is
Yes.
in all places we put the lot like that, we put the words
Dot crystal is, that word is taken from the crystallography information file.
So basically, what is the difference between these two space groups?
That is P is primitive with screw one is twofold screw axis along seat like plane. This N is like the N is also lightning perpendicular to centrist.
Some places you could probably have 30%.
The electron density around that atom. The electron density cloud around that particular atom is 30%.
It is related with your rectangular
Probability level actually I have 30%. It can be increased using the Platon. 50% probability can probability using the Platon software that is incorporated. The probability of the atoms present can also be increased from 30% to 50%.
some places in pieces in page 25. So this reciprocal surface to the nearest nucleus, that is the external participant. So you put this distance as a 2.2 but the dE plus the dI, so it comes as a 2.0.
Hershey's surfaces, the contact distance. Yes, sir. That is dE plus dI is approximately 2.0. Actually, this is written using the graph that is obtained, 2D fingerprint plot. There the graph is plotted dE versus dI. From the plot I have taken the values and written there 2.0.
Which compound there is one?
Antifungal. Actually, all the compounds are showed a better activity against the standard drug, that is bacterial strain, fungal strain, Aspergillus niger. Among them, B and D showed excellent antifungal activity.
So, what places were
The zone of inhibition of B and D here, the zone of inhibition for standard drug is 7, but for my compound B and D, it is 10. So it exceeds the level of the standard drug. So I say that B and D is best.
and also we typically 60 thermal states. Stability. Regarding the melting point, the stability. Okay.
Melting point was found, the first endothermic peak in the DTA showed the melting point. I have used the melting point apparatus also to measure the melting point of polymer points. They coincided, not exactly, but a little bit discrepancy was there. It is 129.70 for, it is in the graph means it is 120 for me using melting point apparatus. The stability up to 268.04 is seen from the TGA graph. Here, the compounds start to decompose at this point, and that is 268.04.
maximum stability is that is 286.92. That is EM and we have the maximum stability and some kind of
You got the sectors by direct method, no?
yes.
Why you go for refinement? Will you got the sector?
Yes, right. So data was reduced and given, and then I did the refinement. No?
Select yes, 97 gave you the sector, full sector.
Yes, sir.
Now you know. Then why you go for refinement? What do you mean? Why you go to
Refinement, isotropic, and first I considered all the spheres were spherical in nature. That is isotropic refinement. Then anisotropic refinement was introduced for considering the thermal vibrations also. So after refinement only I got.
was there any problem with the sector solution?
Solution.
That's why you go for refinement?
No, sir. No, the actually the observed structure should match with the calculated structure. So I want to proceed.
No, it's simple. You got the sector.
Yes, sir.
Whatever molecule you wanted, you got it from select yes, can go.
Yes, sir.
Yes or no?
Yes. Then I fixed the atom, hydrogen atom, then all the
No, is there any flaw in the sector? Or in the
The phase
assumption
from-
of getting the sector? You have given no word. Have you assumed anything in getting the sector which you want to modify later by refinement?
After refinement, was the structure modified?
What are the basis for direct methods?
Okay, the other way, in getting the structures, have you assumed anything which you are overcoming by going to refinement? Then basic. In getting your structure solution, have you assumed anything which you are compensating by doing refinement? That is the right answer. But what are the assumptions which led you to go to refinement? Don't be tension. Just you got to degree, no problem. So, Usha, I give you two also. Do assumptions.
phase problem has to be overcome after the substructure.
Why you talk about isotropic, anisotropic? In your solution, you are not assuming anything. You come isotropic requirement, anisotropic requirement, right? So in your certain solutions, these are not assumed or
The art factor not part of the solution.
Yes, the R factor keeps on going down. That is the
refinement. What made you to go to refinement? Basics. Okay, direct assume non-vibrating point atom, non-vibrating.
thermal vibration.
If the assume there is no vibration, which is against the physics of physical laws, no. That is why I object in case. Right? The mathematical and the direct chemistry doesn't know. The physics begins to tell that, no. They assume atoms are non-vibrating and also they assume that to be point atoms.
Point atoms.
Point atom there is no spherical atoms. That's why they put equal atoms. They assume for easier mathematics, all atoms contain same number of electrons, no vibration. This is not a solution. Now we go to reality. Right? Let atom and no vibration. First we assume acid, then equal vibration, then unequal vibration. Okay. Usha does everything what you supposed to. Did you? Did you? Yeah. Thank you.
So we all, including Professor, accept the
You want that? Excellent.
Acknowledgement. First and foremost, I thank Lord Almighty for giving me this opportunity and good health to complete my research work. I sincerely and wholeheartedly thank my guide, Dr. Usha, who has been my constant support and guidance and motivation extend to me throughout my research work. I am really indebted to her. And to be honest, I have never seen a grade like her. I register my gratefulness to Dr. Viva Maheshwari, Principal Queen Mary's College, for providing all the facilities to carry out my research work. I am grateful to Dr. Himamali Rajagopal, Head Associate Professor, Head of the Department, PhD and Research, Department of Physics, Queen Mary's College, for her moral support to complete my research work. My sincere thanks to Dr. Logan Jonathan, Associate Professor, Department of Chemistry, Madras Christian College, for his excellent effort and guidance in synthesizing the compounds. I wish to express my gratitude to Dr. Johanna Christian Prasanna, Associate Professor, Department of Physics, Madras Christian College, my well-wisher, my previous guide, and also my doctoral committee member for his constant encouragement and valuable suggestion given to me during the tenure of my research work. A special word of thanks to Dr. Anuradha ma'am, Associate Professor, PG Research Department of Physics, Queen Mary's College, for a timely help to start my research work. My sincere thanks to Dr. Satya Pratibha Revatis, Dr. Srinitya, Dr. Vasanti, Dr. Elasi, Dr. Gomati, Dr. Rao Tendal, Dr. Sumaya, Dr. Brinda, and my fellow researchers, Dr. N. Krishnapriya, Dr. J. Himalata, Mrs. K. Lavanya, Mrs. Anish Fatima, and Ms. R. Yuvashri for their support and help throughout my research work. Thank you, friends. I wish to express my heartfelt thanks to the staff members and lab assistants of the PG and Research Department of Physics, Queen Mary's College, for their help and support. I find no words to express my gratitude to my family members. Just a word of thanks may not be sufficient, but still I express my special thanks to my husband, Mr. K. Williams, my sons W. David Isaiah, W. John George, my in-laws, Jairaj Godindan, Prema. My heartfelt thanks to my parents, Mr. C. David Wilson, Mr. Sisters, Agent Sukanya, Dr. Sandra and Usha for holding me in my prayers and encouraging words. A special word of thanks to my brother, Mr. D. Colin David, and Mrs. Chandra, Daughters Iva, Anish, and Vaishwa. My sincere gratitude to one and all present here who directly or indirectly helped me in my research. Thank you. All the way from Bangalore to attend speeches.
based on whatever sector presentation by the candidate, and also the report given by the mark examiner and the Indian examiner, and also the clarification from participant side, also from professor. And all we accept that for the defendant is Viva, and also we appreciated the presentation. Based on this merit of the thesis and also the publication by the candidate in 4 different journals, indexed journals, and also she presented that she made different oral and poster presentation, rest of all. So based on all these merits, and so we recommend supervisor recommends that the thesis and the Viva's examination is accepted by the forum, and also the report is given to the university that Angeline. So Miss Angeline presented well, and hereafter, after the Viva's examination, from this moment onwards, so he may be called the doctor.
First of all, I would like to congratulate Mrs. Angeline Shirmila for her wonderful presentation and answering all the questions, almost all the questions, on my own behalf and on behalf of you all. It is my pride moment. With lots of joy, I'd like to extend my thanks to each and every one of you present here. எனக்கு இந்த நிமிஷம் அப்படிங்கிறது ரொம்ப 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 முக்கியமான ஒரு நிமிஷம். ஏன் அப்படின்னா என்னோட கைடு ஆல்மோஸ்ட் இது 13வது ஸ்டூடெண்ட் அப்படின்னா கூட 10 ஸ்டூடெண்ட்டுக்கு அவர் இங்கே வந்திருக்காரு. இந்த வகையில் ஐ எம் பிளஸ்ட். நான் கிட்டத்தட்ட என்னோட 2000வது வருஷத்துல நான் அவரை மீட் பண்ணினேன். எனக்கு PhD பண்ணணும் அப்படிங்கிறது வயா என்னோட ஃப்ரெண்ட் மிஸ்ஸஸ் சுந்தரி பாஸ்கரன் அவங்க வழியாக போனோம். அன்னையிலிருந்து இன்ன வரைக்கும் I didn't see him tired. அன்னைக்கு பார்த்த அதே ஒரு டெம்போ, அதே ஒரு ஸ்பிரிட், அதே ஒரு எனர்ஜி. நேற்றுக்கு நைட்டு நீங்கள் நம்புறீங்களா என்னன்னு தெரியல, நேற்றுக்கு நைட்டு 1 o'clock he landed at the airport and he was there at Vadapalli at about 1:30 and now today morning by 10:45 he is here to attend the Viva. So this is the platform given to me by Professor Velurugan. எப்பவுமே எனக்கு அந்த இதை சொல்லணும், நான் அவரை தேங்க் பண்ணணும், எப்பவுமே நன்றியோட இருக்கணும் அப்படிங்கிறதுக்காக ஒவ்வொரு வைவாக்கும் நான் கூப்பிடுறேன். He is nearing 70. அந்த ஏஜ் இது பண்ணி நான் வேண்டாம் அப்படின்னு கூட சொன்னேன். நான் நைட்டு வர்றீங்க, நீங்கள் வேண்டாம் அப்படின்னு கூட சொன்னேன். பட் he told me that no, I missed one of your students' Viva 2 days before. So I'll be there by 10:45 shortly. ஸோ நான் காலையில் கால் பண்ணேன், பயந்துட்டீங்களா, நான் வரமாட்டேன்னு நினச்சிங்களா அப்படின்னு சொல்லி கேட்குறாரு. நான் I'll be there in time அப்படின்னு. இது எவ்வளோ பேருக்கு கிடைக்கும் அப்படின்னு எனக்கு தெரியல. பட் really I thank Professor Velurugan for all his support, encouragement and actually his presence for all the Viva examinations of my students. I would like to register my sincere thanks and gratitude to Dr. R. Mohan Kumar, our external examiner for today's Viva examination, for readily accepting our invitation to conduct the Viva examination for Angeline Shirmila. Thank you, sir. It is my pleasure to register or record my sincere thanks and gratitude to our principal, beloved principal B. Uma Maheshwari, and our beloved head of the department, Dr. Hemamalini Rajakumar, for all their undemanding support and encouragement throughout my research career in this institute, Women's College. I would like to extend my heartfelt thanks to all my colleagues in the department, all my friends from other departments, research scholars, and PG students of our own college. Thank you all for having come over here to attend this Viva examination. I could see people in great number from Angeline Shirmila's family. This is the first time I am witnessing such a crowd from a student. நிச்சயமாவே எனக்கு ரொம்ப ஆச்சரியமா இருக்கு. இவ்வளோ பேர், more than she told me yesterday that some 15 people they expected அப்படின்னு சொல்லி. So really this is the first time I can able to see people for a particular candidate. Thank you all for having come over here to attend this Viva examination. Thank you all.